Hello everyone. So today we will be discussing based on the topic SR latch on digital electronics. So let's see what is the SR latch is about. So SR means set and reset. S is based on set and R is based on reset. So a latch is nothing but a sequential circuit in which its output not only depends upon the current input but also the previous input as well. Now let's see the working of its circuit, so you will be getting a clear understanding. So before that, let's see what all elements are there in the circuit. So here in latch we are going to deal with two inputs, which means my set and reset. Then I'm having two outputs, so I'm going to name it as a Q and Q dash. So whatever value that you are going to give as a Q, suppose I got 0, so the complement of 0, which makes 1, which will be my Q dash. So and suppose in set I'm giving 1, so reset means it is changing, right? Changing the value, so it will become 0. This is just for your understanding. So this is all the elements that we are going to use in the latch circuit. So this is just a block diagram. So let's see the working of the SR latch. Now, before that, let's see what is the NAND gate, what is the speciality of NAND gate. So I hope in the logic gates we already studied what all are the different kind of gates are there in digital electronics. So here we are going to implement all these things by using a NAND gate. So that is why we are just summarizing what is a NAND gate. So here in NAND gate, this is the graph, you know that, complement of a NAND gate, AND gate. So here my input is A and B, and by using this NAND gate, see, if both of the input is 0, I am getting the value 1 because I am taking the complement of AND gate. So in this AND gate, the NAND gate, the speciality is that if any one of my input is 0, I am pretty much confident that my output will always be 1. Because when you analyze this particular table, see here in 0 I am getting a pair as 0, with 1 I am getting a pair as 0, here see with the 1 I am getting a pair as 0. So in this case only I am getting both of my inputs are 1. So here I am not confident enough to get the value as true. So in all other scenarios I am getting the value as 1, which means I can give a particular statement that if any of the input is 0, definitely I will get my value as 1 or value as true. This is the only thing that you need to keep in mind while you study what is a latch circuit. Now, this is the circuit diagram for the latch circuit. So we are going to construct it by using the NAND gate. So you should be thorough by drawing the circuit diagram for the latch. So this is the truth table that we are going to maintain. So we are having two inputs, as I mentioned before, set and reset. Then Qn plus 1. So as I mentioned before, this Q and Q dash will be our output, or you can write it as a Qn and Qn dash. So this Qn and Qn dash is nothing but my present output with respect to the S and R, because this is the two input that we are going to give. Now Qn plus 1 means my next stage. My next stage output, we call it as a Qn plus 1. Now let's see different scenarios, because this is our truth table. So each scenarios, each stages we are having different kind of outputs, because our input is nothing but S and R. So here we are giving two combinations like 0 0, 0 1, 1 0 and 1 1. I hope you know this combination. So with this combination we are going to construct the SR latches based on each cases. Now here case 1, consider the case 1. So here I am going to take, instead of taking 0 and 0, I am going to start with 0 and 1. Now suppose S is equal to 0 and R is equal to 1. So this is the circuit for the NAND gate, latch circuit. So here I substituted S with 0, I substituted R with 1. Now when you observe this particular graph, as I mentioned before, in NAND gate I am pretty much confident that if any of the input is 0, I will definitely get the value as 1 or 2. So here definitely I will get, without any calculations or without any predictions, definitely I will get the value as 1 because my value is, my input is 0. But when it comes to here, I am getting value 1. So I am not sure whether I will get a 0 or 1. I am not confident enough to predict. So what did I done is, here I took this 1 and I put in here, I put it in here. So I took this 1, I drew an extra line, then I put a connection, which means I borrowed this 1 and I placed it over here. Now, in NAND gate, 1 and 1, the combination of 1 and 1, I will get the value as 0. See, this is the way you will be going to get. So, when you get a 0, you were confident enough to get the value of 1, but in the case of 1, you weren't that confident to get the value. So, that is why you borrowed this value and you put it over here, because I can include two inputs, one for here and one for there. So, you can borrow it from here. So, in this scenario, you need to think it this way. So 1 and 1 AND gate, you will get the value as 0. So in the truth table, you can write with the s, when s is equal to 1 and r is equal to 1, you will get the value as 1. Because here you are going to take this value. Please don't use this value. We are going to consider this value only. So that is why I wrote 1. Now consider the second case, if s is equal to 1 and r is equal to 0. So here what did I done is, I substituted s with 1 and I substituted r with 0. So here I was very confident enough to get my value, because as any of the input is 0, definitely I will get the value as 1. But here I am getting 1, so I don't know what is my value. So I borrowed here. So I set a connection. So two inputs, 1 and 1. So 1 NAND 1 makes my value as a 0. Now again discard this value, take this value. So I will get 1 and 0 by combining. When s is equal to 1 and r is equal to 0, I will get 0. Now case number 3. So if s is equal to 1 and r is equal to 1. So here, which means both of my input is same, which means I am not sure whether what is my value, because none of my input is 0. So I can't predict here. So what did I done is, I am going to substitute it. So s, we know the value of s, which is nothing but 1. Now here what did I done is, see, when you analyze this figure, I took q dash and set a connection over here, and q, I borrowed q and set a connection over, I put a connection over here, because you know the value here, right? Q and q dash. Initially we discussed this point. Here this is q and this is q dash. So s borrowed q dash and r borrowed q. So this is the thing that I have written in here. So which makes 1 into s borrowed q dash. So that is 1 into q dash. Now it is going to pass in the NAND gate, which means the whole complement. So 1 into q dash, the whole complement. Now apply De Morgan's law. You know the De Morgan's law, right? Because when we apply the multiplication, it will decomposes into the sum of the individual components. So 1 complement, because we are having whole complement here. So 1 complement plus q dash the whole dash. So you know that q complement the whole complement is nothing but q. Now here the ones, when we take the complement of 1, we will get 0. Now by adding this, we will get q. This is my answer. Now when it comes to r, what did we do? We know the value of r, which is nothing but 1. So r borrowed q. So 1 into q, and it is getting crossed on AND gate. So 1 into q dash. Now again apply De Morgan's law. So 1 dash plus q dash, which means 1 complement plus q complement. You know the value of 1 complement, which is nothing but 0. Then q dash. Then we will get the final answer as q dash. So here in this particular thing, when s is equal to 1 and r is equal to 1, we are getting both as, see, same result, like q and q dash. See, whatever that we have written in the diagram itself, we are getting the same result, which makes my state as a hold. Because suppose when you are pressing a particular switch, so if a person want to switch it off and if another person want to switch it on, so see, both of the things is happening at the same time. See, so this is not being, this should not be happening. So this particular state we called it as a hold state. So a very simple example, both buttons pressed simultaneously. So like switch off and switch on, both is pressed simultaneously, which is not, should not be happening. So this particular state we call it as a hold state. Now last case, which is s is equal to 0 and r is equal to 0. Here, here we are getting both the value as 1, because in the initial stage we discussed, right, if any of the input is 0, definitely I will get the value as 1. But see, both of the value is 1. It should not be happening like that. Whatever value is there, here it should be its complement. But here I'm not getting like that, which means my state as a invalid, which means whatever is there in my current direction. So which means neither of them are active, right? So this is nothing but a invalid stage. So I hope you understood the different scenarios of a SR latch. So here you should specifically know what is the usage, the applications of a NAND gate, the speciality of a NAND gate, then analyze each steps. So you can start it from here, then substitute the values for S and R. So you need to consider each and every scenarios. So when S is equal to 1 and R is equal to 1, the state will be on hold, and when S is equal to 0 and R is equal to 0, the state will be invalid. So this is the both things that you need to keep it on your mind. In other things, it's all around substitutions and all. So this is all about the latch, the working of the SR latch circuit. Thank you.